Hi, welcome back to section 9.3. The next thing we're going to look at is compositions of functions. So what's going to happen here is we will have a couple of different functions. So let's call them f and g. If f and g are functions, then that composition of function or composition of f and g and f, it's going to look kind of like this. So there's two different notations. There's like a g with a little circle than an f. That means composition. Or you could do the g of f of x composition notation. So both notations are listed there. So basically what's going to happen is that inside function, you'll notice the f of x is on the inside of there. That's going to be your first one that you do. So the x is the very middle. So the x is the input into your f of x function. And then you're going to get an output. You'll get some answer. And then that goes into the g of x function. And then that output is the g of f of x function. And so it's like going through the machine twice. You're going to put your x in to your f of x function, get an answer, and then you're going to put that answer into the g of x function to get the g of f of x. Okay, so that's what these compositions look like, is doing one function and then putting that into the other function. So let's try a few. So the functions that I have for us, in example 4, we have f of x is going to be 3x plus 6. G of x is x squared minus 2. Just kind of make it a little interesting and different. The first thing we're going to do is g of f of 2. Or if you want to rewrite this, this is the same thing as g of f of 2. So what we're going to do is we're going to put 2 into the f function. We'll get an answer. And then after we get f of 2, we'll plug that into the g function. Okay, so we're going to start on the inside. You kind of work your way from the inside out on these. And so we're going to put 2 into the f function first. So we're going to do f of 2, which is going to look like 3 times 2 plus 6. We're going to do 3 times our x, so x is 2, and then plus 6. 3 times 2 is 6, and 6 plus 6 is 12. So now I've got f of 2 is 12, and what we're going to do is now we're going to do g of that f of 2. Well, f of 2 is 12, so we're going to do g of 12. So you notice we started with 2, that was our input. We put it into that f function, and then our output was the 12. So now the 12 is going into the g function. Okay? Putting the 12 into the g function, x squared would be 12 squared, and then minus 2. Let's see, 12 squared is 144, and 144 minus 2 would be 142. So g of f of 2 is 142. All right, what if I did the other way? What if I did f of g of 2? Would I get the same answer? That's always a fun question to ask, right? So that's what we're doing in part B, is f of g of 2. Oop, too many parentheses there. So what we're doing is we're going to do g of 2, and then we're going to plug that into the f function. We're going to do f of g of 2. So we're starting on the inside, we're going to put 2 into g. So putting 2 into g, we would do x squared, so that's 2 squared, and then we'll subtract 2, because that's the rule for g of x, is x squared minus 2. 2 squared is 4, and 4 minus 2 is 2. So g of 2 is 2. So now that we've got that output, now we're going to plug it into the f function. So I'm going to do f of 2. So I'm putting this 2 into the f function. F is 3x plus 6, so I'm going to do 3 times 2 plus 6. 3 times 2 is 6, and 6 plus 6 is 12. So f of g of 2 is 12. You'll notice that you get different answers, and so it does matter which order you do things in. Okay? Next up, what about just like a generic x? What if we weren't just putting in a number? What if we wanted to keep it kind of as an expression? So we're going to do f of g of x first. So that's the same thing as we're going to do g of x, and we're going to put that into the f function. So that's f of g of x. All right, starting on the inside, the x is going to get put into the g function. So putting the x into the g function, that's x squared minus 2. So now we're really doing x squared minus 2, and we're putting that into the f function. So what that's going to look like is 3 times x, but instead of x, now we're using this whole thing. We're going to substitute that in x squared minus 2, and then plus 6. So 3x plus 6, but instead of x, now we're going to use that g of x function, the x squared minus 2. We can simplify this quite a bit. So let's go ahead and distribute. 3 times x squared is 3x squared. 3 times a negative 2 is a negative 6. And then we can combine like terms. Negative 6 plus 6 is 0. So we just end up with 3x squared. In case you're curious, hey, how does this relate to that f of g of 2 that we did in part B? You guys remember in part B, we did f of g of 2, and we got 12 as our answer, right? Well, the nice thing is we just did a generic f of g of x. If we put 2 into this expression that we just got, we'd have 3 times 2 squared, right? And you would do exponents before multiplication. 2 squared is 4. And then we multiply it by 3. And we would get 12 just like we did in part B, which is pretty cool. So that's a nice way to check yourself and make sure that everything's lining up the way it's supposed to. Alrighty, in D we have g of f of x. So this is we're going to do f of x first. And then we're going to put that into the g function, okay? So x goes into f first, so that'll be 3x plus 6. And then we're going to put 3x plus 6 into the g function. So the g function is x squared minus 2. So I'm going to do, instead of x squared, we're going to do 3x plus 6 squared. And then we're going to subtract 2. All right, little refresher here. Remember that 3x plus 6 squared, that's the same thing as 3x plus 6 times 3x plus 6. That's the whole thing squared. So it's that parenthesis multiplied by itself twice. We do have to distribute. So we're going to do 3x times 3x, which is 9x squared. We're going to do a 3x plus 6, which is 18x. We're going to do a 6 times 3x, which is another 18x. And 6 times 6, which is 36. And I'm not going to forget my minus 2 here. We'll bring it down along with everything else. Combining like terms, 9x squared is the only x squared. But we've got an 18x plus 18x, which is 36x. And then we've got this this 36 minus 2, which would be a positive 34. So this would be the expression for g of f of x. Now it's your all's turn. You get to try one and show me how much you've learned.